Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and on today's episode, we're going to do another of the Getting Started series. And remember, the Getting Started series are where we take a look at a topic that is popular and people kind of know about, but aren't necessarily doing, and we just go from scratch and we learn how to get started doing it. And our topic for this episode is unit testing. There's absolutely no question that we should all be testing our code better, and one of the best ways of doing that is to adopt unit testing. So no question we should all be doing it. Also no question that a lot of people aren't necessarily doing it. So what I want to do is start from scratch and say what is unit testing, and then just show the basics of how you get started doing unit testing. And I'm going to do it a little bit differently than the previous couple getting starteds, the MVVM one and the source control one, which I did all at once. I've got over an hour's worth of content here, and rather than do it in one episode, I'm going to break it up into at least two parts. So this first one will be Unit Testing 101. It is the absolute very basics. I'm working from a demo script, so if you see me referring to my notes, that's why. This is from a hands-on lab that debuted at TechEd, and I'll be making publicly available in the relatively near future. So what is unit testing? Unit testing basically is a way to make you a better developer. And you become a better developer by obviously writing better code. Unit testing isn't about elegance of your code. It isn't about efficiency and performance. It's about writing code that works. So the best thing you can do to be a better developer and build better apps is to write code that works. And the best way to make sure your code works is to test the heck out of it. And unit testing is all about breaking down your code into individual pieces that you can test repeatedly over and over again. So you break your code into units, and those units are typically going to be methods that perform a task, and then it's a way of being able to test those methods without having to run the entire application. So you can test more regularly, you can test more efficiently, you can test more often. And that, in a nutshell, is what unit testing is. So let's say we're building an application. For our demo here, we're going to build a calculator. Okay, we're going to work on the code that gets called from the calculator. We're not going to worry about the UI in this episode. We're just going to focus on the code. So let's create a new project. And it's going to be a class library. And I'm going to call it my calculator. Okay, and let's rename this class to calculator or calculator. Okay, so now what goes in the calculator? Methods go in the calculator that do things. So for example, we would have a method that adds. So the method is called add, takes two parameters, these are integers, it adds them, and it returns the result. Okay, pretty simple code. I'm going to keep this fairly simple. Okay, so now what we want to do is test this code. Well, how do you test this code? Well, to test this code, the simplest thing to do, of course, would be to create a console application and then add a reference to the library and then write a method which adds and then test that. But you see what happens is you have to build an application. You have to build a console application. You have to build some UI to test this code. And then every single time you want to test this code, you have to fire up the UI. And how do you automate the testing of this? So, well, the answer, of course, is by doing unit testing. So the next thing we're going to do is to create unit tests around this code. Visual Studio has a very robust unit test framework, and the thing we're going to do here in this solution is we're going to add a new project. We're going to go into the test section here, and we're going to add a unit test project. And we're going to call this mycalculator.tests. This is a convention. Typically, what people do is the name of the testing project is the assembly you're testing .tests. You absolutely don't have to do that, but that is a convention that's worth following, and I'm going to follow it. Okay, so now Visual Studio creates this project and references the Microsoft.visualstudio.testtools.unittesting namespace, which is basically the unit testing framework. Okay? And what this gives us, among other things, are these attributes where we attribute this test as a test class, meaning that it is a class that will contain test methods. And then we have a method here called test method 1, and that's attributed test method as well. And those attributes are how Visual Studio knows which tests to run and how to run tests. Okay, so I'm going to rename this. All right, don't want to rename it. I just want to make sure that I am, following my notes. Sometimes if I don't follow the notes rigorously, I get lost. Calculator tests. Okay, don't have to do this, but I just like to. All right, so now what we want to do is add a reference to the project, my calculator. So let's add a reference to the actual code we're going to be testing. Okay. All right, so now let's do this. So now what we're going to do is we're going to add a reference to that, our calculator, and then what I want to do is give this a better name, add simple. Okay, so now what we have is a class of tests. We have our basic test here. We have a reference to the code we're going to test. Now we're ready to start writing our tests, writing the body of the test. And the pattern that is typically followed, AAA, is arrange, act, and assert. So it's basically 3 steps. So let's add some code and then see what that AAA is. Arrange, act, and assert. So the arrange is where we set up the environment. What do we need to do before we can start running code? Well, we create a new reference to the calculator class. Then we act, we take an action, we actually do the addition. We add the numbers 1 and 2. We pass those into the method, and then we retrieve the result. And then we assert, and the assertion is where we know if the test succeeded or failed. And so we say assert.r equal 0 in sum, saying that after we take this action, we're going to assert that this method returned a 0. Okay, now if you look at this, you're thinking to yourself, oh my God, Green, where did you go to school? 1 plus 2 is typically not equal to 0. Well, a good pattern that a lot of people follow is you write the test to fail first. That way you're sort of testing the test. Once you know that the test runs, then you change the assert to actually succeed. This kind of weeds out some false positives or false negatives. Okay, so again, arrange, set up the environment, act, run the actual code you're testing, and then do an assert. Now we want to test this. And to test, we'll typically be using the Test Explorer window. If it's not available, then you go to Test, Windows, and call up the Test Explorer. And the Test Explorer is going to list all of our tests and show us what the results are. Notice that nothing shows up in here yet because you need to build the project before the tests appear. So let's build this. And now we have a test called add simple. Okay? So to run this, there's a number of things we can do. We can right-click on it and run selected tests. We can click run all in here. We can also right-click inside the method and choose run tests. Those all work. So now let's run this test and see if the test actually runs and what happens. We see how long it took. This bar was green while it was running and then turned red because the test failed. And the test failed because the assert failed. We asserted that this add method is returning a 0 when in fact it returned a 3, which of course is what we want. But what we now know is that the test runs. So we've got an X here that showed it failed. Notice in the code, and this is a feature of CodeLens, which is in Visual Studio Ultimate, we see that there's an X, so it failed. And of course, if we went to the add method, I was trying to press F12. There we go. Then we see that it's 0 of 1 passing, so we see that failed. Okay, so now that we know that the test works, that the test runs properly, now let's make sure that the code works. You can skip this step if you think, oh, that's a lot of work to do, I'm going to skip that. Feel free, but A lot of people will start out by writing their tests this way. Okay, so now what we're going to do is rerun this. Let's run the selected test. And now it works because we asserted that this returned a 3, and it actually did return a 3. Notice in the code lens we get a green circle with a check mark, and if we go to the add method, we see that 1 of 1 are passing. Okay? All right. So in a nutshell, that's basically unit testing, right? I mean, we could stop here and say, all right, now you now know how to unit test. What you basically do is create a unit test project, create a class of unit tests, create methods that will actually test your code, attribute them test method, and then arrange, act, and assert. Now, there's another way of doing testing, and that's something called test-driven development. And the idea there is that you write your tests first, and then you write the code. So, it kind of depends. If you're in the middle of a project where you've already got code, you're going to add unit tests to them. If you haven't written the code yet, or you're starting from scratch, then you can think about whether you want to adopt test-driven development. The idea here is that it's a way of helping you write more testable code, and also a way of ensuring that you write the tests because you have to write the tests first before you write the code. So let's do that. We're going to add a feature to this calculator, which is the ability to divide. Okay? So what we would do is write the test first. So we're going to have a test method called divide simple. We create a new instance of the calculator. We pass in 2 numbers to a divide method, which doesn't exist at the moment, of course, because we haven't written it yet. And then we assert r equal. I'm going to skip over the part where I start out at 0, and I'm just going to enter the correct result here. Okay? So now that we've written the test, we can now go write the actual code. All right? And we know the way this works. We've practiced how you call it, right? We've written this, and we're saying that this divide method takes 2 arguments, and it's going to return an integer. So there's a little bit of designing of the method, at least the interface of the method, before you actually write the code. So if we go into the calculator now, we would do something like this. Public int divide, which takes 2 integers, one which is the dividend, one which is the divisor. Okay. Now, if you want to just, again, test the tests, we can just return a 0 from this. So we haven't actually implemented the divide yet, but we're testing how, we're testing the test, if you will. So again, we're not going to change this to a 0. We're going to run this method, and we've tested the test. Okay? All right. So now let's go implement the code. Again, you might decide, I don't need to do that. You might decide that's more work than you want. For simple code like this, you can decide whether or not it's worth it. If you're doing more complicated things, if you're going to spend an awful lot of time in code, if it's going to be fairly complex and you want to get the test set up first, then it's a good idea to just return a dummy variable and then check the test. Okay. So now, build this. We can come back in here and come into our tests. Right-click on here, run the tests, and this divide simple works. If we want to run all of our tests, we can click Run All, and then all of the tests run. Now, so again, notice that we haven't created any UI. If I want to test a test, if I want to run a test, all I have to do is right-click and run selected tests, or run all. I don't have to build any UI. I don't have to create any scaffolding for this. I'm literally just testing the test. So if you think about it, I've written a bunch of code. I have a bunch of tests. I now want to know, do these tests work? I'm about to go to lunch. Come over to Visual Studio. I click Run All. I leave. I go to lunch. I come back, and I can see what tests ran. Okay? So the big benefit of unit testing is the ability to test individual pieces of code, these units, over and over and over again. It's now really, really easy to run this test. I don't have to build a UI. I don't have to run the application, go into the calculator, hit 2 plus 3 equal, and then see if a 5 shows up. I'm just literally testing the code. Okay? All right. So there's when we did the add, we don't need to test this add method to see what happens if you pass in zeros or negative numbers, because you can add 0 and 0, it returns 0, it works fine. But in the dividing, we need to understand that somebody could pass in a 0. So what I want to do is create another test method that's going to check for divide by 0. Okay. All right. So fire up a new calculator, divide by 0. Let's run this method, run this test. And notice that it fails. And it failed because it threw an exception. It threw a divide by 0 exception. This is kind of ironic. The code did exactly what we thought it would do. You would think that if you divide by 0, you'd get a divide by 0 exception. And in fact, that's what happened, but the test failed because of that exception. So how do we tell the method to expect the exception? It's not done through an assert. What it is done is through an attribute. So I'm going to add to this, an expected exception. And I'm going to say we're expecting a type of divide by 0 exception. So we are informing Visual Studio, we're informing the test framework that we expect this to return a divide by 0 exception. And now if we run this, and I can run the failed tests, now this works. So now we know that this code returns this particular exception. Now, you might ask, oh, very nice. Why? Why would you do this? Well, if you think about it, you not only want to test that the add returns the number you think, that the divide returns the number you think, but you also want to test that the methods behave in a particular manner. Because let's say you are going to write a method, right, called divide, and again, it takes, this is, right now we're in the actual UI of the application. We're going to write code that looks like this. Okay, and what we're going to do is we're going to try. So let's say int result equals 0, and then what we're going to try to do is divide these. All right, we'll do something like this. Okay, then down here need to return result. Okay, so then we're going to start catching. And, you know, if you're kind of lazy, the first thing you do is you just catch an exception, and maybe you set result, I don't know, let's set it to in.min value. In real life, I'm not sure if that is good enough, because what if the calculator literally ever returned the minimum value? But for our purposes here, that tells us that it failed. But the thing is, we don't know why it failed. What I really want to be able to do is catch, let's do it this way. I want to catch the divide by 0 exception, and let's say we return the max value. Okay, so I want to be able to, in my UI, I want to write code that looks like this. So what I'm doing is relying on this divide method, right? Actually, let's make this a little bit easier. just so I don't confuse it too much. Our calculator is a new calculator, and the result is calculator.divide dividend divisor. Okay. Does that make it a little bit clearer? Okay. Okay, so this is the type of code that we're going to be writing in our front end. We're going to call the divide method, and if we pass in a 0, we expect it to return divide by 0 exception. So what we want to be able to test is that this method actually does throw the divide by 0 exception, okay, because that's what we're expecting. If this code gets changed so that when you divide by 0, a different exception gets thrown, in our example here, then this code now is not going to catch the exception we expect. Therefore, you really should test that dividing by 0 returns the expected exception. Make sense? Hope so. All right, so. Okay, so now we've got tests. What else can we do in the Test Explorer? Right now we've just got a list of tests. One of the things we can do is organize our unit tests. So in the Test Explorer, we can do grouping. We can group by traits. We can group by outcome. So we can look at our past tests. And let's now change this, run them all. And now we see that there are two groups, passed tests and failed tests. So at the very least, at the very basic thing, you can group by whether or not the test succeeded, which would give you the ability to then go back and rerun all of your failed tests. So let's say we ran a bunch of tests, most of them passed, a couple of them failed. We went back, changed the code. Now we can right-click here and either run the selected tests or run the failed tests. Okay, and now they're all passed. Or we can group by class. We can group by duration. So fast, slow, etc. I might just want to run all my quick tests. I got 3 minutes before I got to jump on a conference call. So I right-click on this. I run all of the fast tests because it's fast. Or I guess you could run just the slow tests overnight or something. We looked at outcome. We can group by project. Another thing we can group by are traits. Okay, now at the moment, none of these have traits. Traits are a way of basically categorizing your tests. So what I'm going to do is add another attribute called test category. And I'm going to create a category called add. And then I'm going to create a category called divide. Okay, and now when I build this, notice that I have add tests and divide tests. So I can test all of the code to do division or add or multiply or whatever. Or maybe I do something like this. I've got tests for simple math. I mean, realistically, after I prove that I can add and divide correctly, how many times am I literally going to need to go back and do that? You know, on a regular basis, but on a daily basis, I probably don't need to touch the simple math that often. And then I might have a category called exceptions. Okay? So I might, for some of the more complicated methods, create a category called complex math, which would, I guess, be multiplication. And then I can just test those. Okay? Now, let's say I want to do it, run most of the tests, but I don't necessarily want to rerun the simple math tests. But I do want to keep the category. Another thing I can do on kind of a temporary basis is add an ignore attribute. So I'm not going to run the simple math. Now when I run all, notice that the add simple didn't run. It has this triangle saying that the test was skipped. Okay? Test skipped shows up in the data tip here. And then when I want to run it, I can delete this or, of course, comment it out. And now that test will run. Another thing I can do in terms of categorizing is to assign priorities. So I'm going to say that simple math is prize 0, right? If the calculator doesn't add and divide and subtract, then it's kind of pretty useless. And whether or not it returns the exception, I think that's kind of important, but that's really a pri 1. So now I keep my exceptions in simple math, but I now have my prize 0 and my pri 1. So I could run my prize 0 tests and make sure that they're still working. There are other things you can attribute for this are description, owner, there's a couple addition, timeout, work item, etc. But these are the basic ones. So that, and we're going to stop here, right? We said we were going to do this in multiple iterations. I think this is a good place to stop for this episode. This is the basics of unit testing, right? This is unit testing 101. How do you get started unit testing? What can you do with it? Remember, the idea is to make you a better developer by giving you the ability to write better code, defined as code that works. And in order to know that your code works, you got to test it. You got to test it over and over and over and over again. And by creating unit tests and letting Visual Studio create the unit test project for you, and then just creating unit tests, it's very, very easy to test code over and over again. By categorizing and by grouping, you can run certain tests. You can just run them all, and it kind of gets you in a habit of you've built the code, you go to lunch, you just run the tests. You build, you're going to leave for the day, you run the tests. Before you check in, you run the tests. Run them all, run just the ones that failed, categorize, group them, however you want to do it. Very, very easy to get started. There's obviously more involved with unit tests, and we'll explore some of the stuff in the next episode. But to just get started, it's really quite simple. And so if you're not currently doing it, I highly encourage you to. At the very least, build tests after you write code, but also give some thought into doing the test-driven development, where you write the test first. If you want to learn more about that, there are blog posts and articles, entire books on the subject. Go explore that, but at the very basics, you have code, write unit tests, and test. Hope that was useful. Let me know if you like the idea of breaking these into smaller chunks, or if you're thinking, well, we're just getting started, we should go on for another 30 or 40 minutes. Let me know, and I'll see you next time on Visual Studio Toolbox.